Future Makers.
Let's make a scene machine. With this FutureMakers Spark, your learners will animate a scene using mechanisms that turn and move a mechanical sculpture called an automata. They'll integrate engineering, visual, and language arts skills to design, test, and share what they create. Here's what each learner receives to make a scene machine: a laser-cut cardboard sheet, 4 standard and 1 jumbo paper straws, a set of special foam followers and cams, a visual guide, and a reusable reclosable bag. We encourage you to print a scene machine planning sheet for each learner to help them sketch and prototype prior to making their final project. Your learners will also need paper or thin cardboard, scissors, tape, and art supplies to create components for their scenes. To start, we'll remove some parts to fold the frame that holds the mechanisms for our automata. Remove the corner pieces and set them aside. The circles can be used in our moving parts. The pieces with slots can help the frame stand up. The board has perforations that help the frame fold. Leave these parts attached. We'll use these to connect the tabs and slots to make our frame. Fold both long sides up on the perforations. Hold them in place and fold one short side so its slots align with 2 tabs. Join them together so the tabs hold firmly. Repeat for the opposite side. If you need to, bend the tabs to lock them in place. Let's get to know how our moving parts work. We're going to create a round and round mechanism to practice. It makes something rotate when you turn an axle. This mechanism has 2 axles with special components attached. They're made of foam discs and straws. The horizontal one has a cam. It's the source of the mechanism's movement. The vertical one holds a cam follower. It rolls when the cam on the main axle turns. There's also a guide tube that helps the axle spin smoothly. You'll need scissors, a jumbo straw, 2 standard straws, and your foam parts sheet to start. Cut a piece of jumbo straw that's just as long as your pinky finger. Carefully press and twist the straw piece into a hole on your frame. We're using the center hole here for our example. For the cam and follower, take 4 foam parts out of the sheet, 2 small stoppers, a large disc, and a medium disc. Insert an axle into the guide tube. Add the large disc at the bottom to make a follower. Use the center hole of the disc. Insert a straw into a side hole. This will be the axle that holds a cam. Add a medium disc and feed the axle through the hole on the opposite side of the frame. Add a small stopper to each end of the axle on the outside of the frame. Adjust your stoppers to help align the cam. The follower sits on top of the cam. They should make contact and rotate when they turn. We're using the cardboard discs from the frame to observe the direction that the follower turns. If the cam is on the left of the follower, it will rotate one way. If the cam's on the right, the cardboard disc will rotate the opposite way. A round and round mechanism is a perfect way to get to know automata basics. Spinning mechanisms are a great way to spark a simple story or bring something to life. It's easy to add a second rotating element to any scene. Just add another cam and follower to the machine. This opens up learners' ability to design scenes that show relationships between two subjects, or a subject with two moving parts. What's the story that you see being told in these scenes? How do you think they were engineered to turn in unison or in opposite directions? Scene machines are a playful way to explore narrative and storytelling through engineering and art. This activity can start simple and grow more complex as your learners become familiar with different mechanisms and linkages, and imagine ways to illustrate and develop their scene ideas. This project was inspired by the amazing automata resources created for educators from the Exploratorium and the Cabaret Mechanical Theater collection of automata at the American Visionary Art Museum in our hometown of Baltimore, Maryland. Once your learners have explored round and round mechanisms, they're ready to try something more challenging. Here are two more movements, each a bit more complex than the last. A small change to the follower and cam can turn something that goes round and round into up and down movements. Locate the offset hole in the disc and insert the axle through it. Align the follower and the new offset cam and give it a turn. The follower will go up and down and turn at the same time. The large cam makes the up and down motion bigger. Use different size cams for different effects. Up and down movements can take on a whole new dimension for learners' projects. They can easily add a second mechanism to these machines to make even more unique moving scenes. Side-to-side movements require a more complex combination of components, perfect for ambitious learners who want to stretch their skills, troubleshoot, and persevere. This mechanism uses a pair of offset cams and a linkage connector that moves up, down, and around on a spinning axle that goes through it. You can remove the guide tube for this mechanism so the straw can move freely from side to side. You'll need scissors to shorten a straw for this approach. To create the offset part of the axle, you'll need two cam discs, the linkage connector, and a collar. Slide the collar onto the connector, insert a straw, and slide the collar backwards to lock the straw into place. This part becomes the linkage that moves using the offset cams. Add stoppers to keep the mechanism on track. The larger cams can make large movements. The medium cams are more subtle. The cams need to be oriented to keep the short axle aligned. Combine these parts with two pieces of axle. Test it to get your movement steady. What kind of scene could your learners create with this mechanism? With side-to-side movement, stories really get moving. Scene machines are primarily about telling visual stories. Mechanisms are only the start of the project. The scenes learners design are the bulk of their learning. Your role is to guide learners through the process of engineering a story. We've created a two-stage scene machine planning sheet that supports planning, prototyping, and final engineering, a whole scene machine design process. During stage 1, they'll need to brainstorm and prototype. Your learners describe their scene in one sentence and pick one or two mechanisms to bring it to life. Their choices should be at a level that's right for them. It's important to use the frame in an interesting way. Learners need to imagine and show how they'll disguise the frame in their sketch. Sketching 2 or more ideas for their scene is necessary before prototyping and testing. Be sure that their mechanisms are labeled so it's clear clear how elements could move. With sketches complete, learners then build a prototype. It's not the final version. Your learners should use tape and paper with quick sketches to create a simple version that helps them test and validate the mechanisms they choose. This lo-fi version of their idea can be changed quickly, and components can easily be swapped. With their prototype complete, learners are ready for stage 2, to plan their final scene machine. Now they give their machine a title. They list up to 3 improvements that will be made in the final version. Most importantly, they create a detailed final sketch with mechanisms that are clearly labeled. Final versions will require more access to art and craft supplies so they can draw, cut, and build features of their scenes that disguise the frame and bring the scene to life. Learners may find that the follower axle straw might stick out too far and prevent mechanisms from moving. Adjust the ends of the axles so they don't contact cams. Sometimes other components get in the way, like this guide tube that's stopping the up and down movement. Have your learners look closely to see what might be keeping their mechanisms from moving, and encourage them to troubleshoot before making a recommendation of a change. Cams sometimes slip. Learners can reinforce them with stoppers on either side to help them stay steady. If they consistently slip, wrap tape around the axle to make it thicker. That will hold the cam tightly in place. Congratulations on creating a scene machine. Every spark your learners make is unique and theirs to keep. They'll remember this project for years to come. Thanks for watching.
FutureMakers.